Today we're going to be talking about the quadratic formula. This is something you have already done in your past algebra classes, so hopefully today is just going to be a good review. Okay, let's look back at the ways we have already learned to solve quadratics. Solving by graphing, which remember we said the roots or the solutions of the quadratic are the x-intercepts of the graph. So this one has two solutions. You can see them here and here. Solving by factoring, truthfully, that is probably the most efficient way, but not every quadratic factors with real rational coefficients. So sometimes that one is not really possible. Solving by square roots is a good method, but sometimes if that b term gets in the way, if it's not a zero coefficient, solving by square roots isn't the best method. Solving by completing the square will always work, but depending on what your coefficients are, you can run into some fairly complex fractions. So all of these methods work in different times. Sometimes it's better to use one than the other. The last one, the one we're going to work on today, is the quadratic formula. Okay, go ahead and write this on the top of your paper. This is something that has to be memorized. I know you already worked on memorizing it in Algebra 1 and also Algebra 2, so we're just going to bring this back to your mind again. And we talked about in the last video how this part under the square root is known as the discriminant, and we're going to focus a little bit on that in this video as well. So let's get to work and solve some quadratics. Okay, here's our first one. So this one is already equal to 0, which is the form that we need it to be in to solve using the quadratic formula. And you saw in the quadratic formula that we had an A, a B, and a C. All right, so let's identify what those are. All right, and we've done this several times. A is the coefficient on the x squared term. B is the coefficient on the x to the first term. And C is the constant term. Okay, so now we're ready to substitute into that formula. Look at it on the top of your paper. You can see that it starts off with negative b plus or minus the square root. And then inside the square root is where the discriminant is, b squared minus 4ac, all divided by 2a. Okay, now something to be careful of. Notice that my fraction bar goes all the way from the negative b term to the end of the square root. That fraction bar needs to cover the whole thing. Sometimes people only put the fraction bar here or they only put the fraction bar here, but that fraction bar needs to go all the way across. So make sure yours goes from the negative in front of the 3 all the way to the end of that 1 in parentheses. And then I'll put 2a in the denominator there. Okay, so now when we get ready to simplify this, basically the first thing we're going to do always is find the discriminant. We're going to substitute these numbers under the square root into our calculator. And remember, the square root part is not part of the discriminant, so I'm not going to type in the square root. I'm just going to type in the 3 squared minus 4 times negative 1 times 1. Okay, that works out to be 17. So let me put that in there. Okay, I'm going to pause right here. Look at the 17. Remember from our discriminant video, 17 is positive. So that tells me that my solutions are both going to be real. And 17 is not a perfect square number, so that tells me that my solutions are both going to be irrational. So I'm going to have two real irrational solutions. In the denominator, 2 times negative 2 is negative 4. Okay, sometimes in a standardized test, or if you have a computer-based college algebra class, they won't leave that negative in the denominator. They'll divide everything up here by that negative. So negative divided by negative is going to be positive 3. All right, now look at the 17. The square root of 17 has a positive and a negative on it. So positive divided by negative would be negative. Negative divided by negative would be positive. So that part, even though I'm dividing it by a negative, it doesn't really change anything. And then the 4 in the denominator would be positive. So even though this is mathematically a good answer, stylistically often we don't like that negative in the denominator, so they're going to rewrite it like this. Okay, so think about a graph. If I had two real irrational solutions, what does that tell me about the roots of this quadratic? Tell me about the x-intercepts of this quadratic. Well, I should have two x-intercepts, here they are, and they should be irrational. So if I were to type this into Desmos and click right here, or I were to type onto my calculator and ask the calculator to find the x-intercepts for me, both of these values would be irrational. The calculator or Desmos would have to round those for me because remember, irrational numbers go on and on forever without repeating and without terminating. All right, let's do another one. Look at this one. X squared plus 6x equals negative 9. Okay, so this one is not in a good form to use the quadratic formula. In order to use the quadratic formula, I need this to be a 0. So the first thing I'm going to do is add 9 to both sides to get a 0 over there on the right-hand side. X squared plus 6x plus 9 equals 0. Okay, now it's in the correct form. So let's identify A, B, and C. That's going to be our first task. Okay, so A, coefficient on x squared. Remember when there's nothing there that you can see, that's the understood one. B, coefficient on x. And C is my constant term. Okay, so let's substitute that into the quadratic formula. So first thing I have negative B, right? So it's always the opposite of whatever this one is. Negative B plus or minus the square root b squared minus 4ac all divided by 2a. Okay, now notice my fraction bar goes all the way across, and notice when I did a, b, and c, I looked at this one that's equal to 0, not this one up here. Okay, so you guys find the value of the discriminant for me. Type that in your calculator. Let's see what we get for the value of the discriminant. Okay, hopefully you got 0. Okay, now think back to what we said about the discriminant. When the discriminant value is 0, what does that tell me about my solutions? Okay, it makes it look like I just have one solution, right? Because negative 6 plus 0 and negative 6 minus 0, both are going to be negative 6. Negative 6 over 2 is negative 3. But remember, because of the 2 right here, we know that this has two solutions. It's just that both of the solutions are negative 3. I get the same solution twice. That's why it looks like two solutions. Okay, so think about this one graphically. If I look at my original equation, what I'm trying to find is the point of intersection of this graph and the line y equals negative 3. So based on what I see right here with the negative 3, I should see one intersection point on the graph because I only have one solution that's different, right? Negative 3 and negative 3, I'm just going to see one negative 3 on the graph. But if I were to graph it from right here, I would be looking at where this quadratic crosses the x-axis. And again, I should see it only touching the x-axis at negative 3. I shouldn't see it cutting through at two different points. So let's see what we see here. All right, first, let's look at this one. Do you see I've got the red parabola right here? That's the x squared plus 6x. And then I've got the line y equals negative 9 down here. That's a horizontal line. And I can see that they intersect at the point x equals negative 3, and that's the only intersection point. So when I only see one x-intercept, what that means is this was a solution twice. And you can see how it bounces right there. That's an indication that I have a double root. Okay, so now let's look at this one. X squared plus 6x plus 9. Well, that's the green one that I've got right here. You can see that its x-intercept is also at negative 3, that same value, and I only see it touching the x-axis once because negative 3 is a solution 2 times, but I'm only going to put negative 3 on the graph once. So when my discriminant value is 0, that means I have two real rational solutions. It's just that they're both the same. So sometimes on a test, you might see that it has one solution because there's only one that you can see. You can't see the same thing twice. All right, let's try this one. 8x squared plus 6x plus 2 equals 2x minus 3. Okay, what is the first step of this going to be? The first step is going to be make it equal to 0. So I need to subtract 2x from both sides. I'm going to line up my like terms and also add 3. I'm going to do the opposite of each of those so that I end up with a 0 over here on this side. On this side, when I combine like terms, I have 8x squared plus 4x plus 5. Okay, you guys see if you can figure out A, B, and C for me. All right, A is 8. That's the coefficient on x squared. B is 4. C is 5. Okay, so now let's substitute that into the quadratic formula. Negative b plus or minus the square root b squared minus 4ac all divided by 2a. Okay, pause just a minute, write that down on your paper in case you missed something. Okay, what's the first thing we're going to do here? Well, we need to type the discriminant into our calculator. So you guys type the discriminant in there. Let's see what we get for the solution. All right, I got negative 144. 2 times 8 in the denominator is 16. Okay, so now remember back to our discussion on discriminants. What does the fact that I have a negative in here mean? All right, it means I'm going to have two imaginary solutions. Okay, square root of 144 is one you may remember from when you memorized your times tables. Square root of 144 is 12, but I have negative 144. That means I'm going to have 12i and not just 12. 16 down there in the denominator. Okay, now look at this. 4, 12, and 16. Do you see that they have a common factor of 2? I can simplify this one more step. Negative 2 plus or minus 6i over 8. Oh, look at that. I didn't find the greatest common factor. I just found a common factor. So instead of going back to the beginning and dividing all of those by 4, I'm just going to divide again. I'm going to divide all of those by 2. Negative 1 plus or minus 3i over 4. Okay, so that is my final solution. Remember, this number up on top is complex. It has a real part and it has an imaginary part. So even though I have two imaginaries right here, positive 12i and negative 12i, my final answer is going to be complex because it has a real part and an imaginary part. Okay, what did that mean for the graph? Do you remember? Well, can I put imaginary numbers on my real graph? Nope. So I looked at this one this time, the one where I had my quadratic equal to 0. So you can see my quadratic right here, and you can see that it's not crossing the x-axis at all because I had two complex solutions, and I can't put imaginary numbers on my real graph. Okay, last one. Let's look at this one. 6x squared plus x minus 20 equals negative 4x plus 5. What's the first step? Right, I need to get it equal to 0. So I'm going to do the opposite of both of these. Move everything over onto the left-hand side. So 6x squared plus 5x minus 25. Working to get my like terms put together. Okay, now let's see if we can figure out what A, B, and C are. So A is 6, B is 5, C is negative 25. All right, let's substitute that into the quadratic formula. Negative b plus or minus the square root b squared minus 4ac all divided by 2a. Okay, so let's find the discriminant value. You guys type that in your calculator. All right, I got for my discriminant 625. Well, that means it's real because 625 is a positive number. I wonder if it's going to be rational or irrational. How do we tell? Well, we look at that number and determine if it's a perfect square number. So I'm going to see if I can take the square root of it in my calculator, see if it's a perfect square number. Sure enough, it's a perfect square. Square root of 625 is positive 25. So that means to finish this one out, I need to actually complete the math in the numerator because now I have like terms. Negative 5 plus 25 is 20 over 12. Negative 5 minus 25, negative 30 over 12. Now I would need to simplify both of those. because they both are able to be simplified. And notice that we cross 2 times. This time I